everybody. We're looking at section 8.3 continued. I am live with block 6. You guys want to give a shout out?
Hey.
Thanks, Billy. All right. So, so we are looking at 8.3 continued. So we're looking at factoring, and factoring is an important tool for solving equations and simplifying rational expressions. And the main thing that you need to take away is that factoring is writing a polynomial as a product of two or more factors. If a polynomial cannot be factored over integer with integer coefficients, then it is said to be prime, and or it's irreducible. So first of all, x squared minus 9 is factorable into x minus 3 times x plus 3, because this is a difference of two perfect squares. That's a perfect square, that's a perfect square, and there's subtraction between them. X squared minus 3 could be factored over the real numbers, but we have to use square roots, and that's not integers, so that doesn't really count as factoring. All right, and then we say a polynomial is completely factored when each of its factors is prime. And so we're trying this example right now. X cubed minus x squared plus 4x minus 4. Here's my suggestion. If there's 4 terms, you probably want to try factoring by grouping. And let's not put parentheses like this. That's dangerous because that can change the meaning depending on what's grouped in the parentheses. So instead of parentheses, let's just put little brackets underneath what we are factoring by. And so what can we factor out of the first 2 terms? And getting some help from Billy.
X squared.
X squared?
Yep.
So what, if I factor on x squared and I put a parentheses, then x squared times what gives me x cubed?
X minus 1.
X minus 1, everybody agree? All right, x squared times x gives me x cubed. X squared times a negative 1 gives me a negative x squared. What can I factor out of the 4x minus 4, Hayden?
4.
4, so I'm going to put a, do you want positive 4 or negative 4? All right, so I'm going to write that we're factoring out a positive 4, and I'm putting parentheses, and Hayden, what's going to be left?
X squared 4.
Yeah, 4 times x gives me the 4x, 4 times a negative 1 gives me the negative 4. And this factoring by grouping thing only works if we have the exact same thing in parentheses. Do we? So that means out of this term and this term, is there anything that's the same in both of these terms? Do they have a common factor? What is it? X minus 1. So I'm going to factor out x minus 1, and then what's going to be left? X minus 1 times what gives me this first box back again? Asha? X squared. And x minus 1 times what gives me the second box? What do I need there, Vivian? Plus 4. Are we okay with this? All right, so go ahead and try this next one on your own. It looks like it's the same, but it's not. There's a couple signs in it. Yeah. Okay, so in this one, did you put a little bracket underneath this, put a little bracket underneath this? What can we factor out in the first set, Jacob?
X squared.
X squared, and then what's going to be left?
X minus 1.
What can I factor out of the negative 4x plus 4? Let's see. Kyle?
Negative 4.
All right, so I'm going to put a minus 4, and then what's going to be left in the parentheses?
X minus 1.
X minus 1. Remember, we can check this. Negative 4 times x, negative 4x. Negative 4 times negative 1 would be a positive 4. Do we have the same thing in parentheses? All right, so our final factored form is going to look like what, Lucy?
X minus 4. And then x squared.
Everybody okay with this? Can we factor either of these factors further? Caitlin? What do you think? Either one? I think this one looks a lot like this one, doesn't it? And we factored a difference of 2 perfect squares. So Caitlin, how would we factor x squared minus 4? Times x. X minus 2 times x minus 2. Do people agree? We need one of a minus and one of a plus. Yes? All right, so I think this would be our final answer for this problem. Questions on this? All right, and moving on. We always want to start by looking for common factors. So in this example, 8x to the 5th minus 6x squared. What would be a common factor? What goes into both of those terms, Brianna? 2 goes into both, so I can factor out a 2. Because 2 goes into 8 and 2 goes into 6. Anything else go into both of these, Vince?
X squared.
X squared. So we could factor out a 2x squared, and then 2x squared times what is going to get me back to 8x to the 5th? Cole?
4x to the third.
4x to the 3rd is 2x squared times 4x cubed. That 2 times 4 is 8. X squared times x to the 3rd is x to the 5th. And then I'm going to need this minus from right up here, right? That minus there. And so, yeah. And so what am I going to have as my next term here, Zoe? So minus 3. Are we okay with this? All right, so that's factoring out a common factor. We should always be looking for common factors first before we try anything else. All right, how about this next example? I got negative 9x squared plus 3x minus 6x to the 4th. Any common factors there? Maddie?
Negative 3x.
Negative 3x. All right, and then if we factor out a negative 3x, Maddie, negative 3x times what is going to get us back to negative 9x squared?
3x.
Positive 3x. Do people agree with that? All right, and then what?
Plus negative. No, wait. Plus. All right, minus 1.
Minus 1. Do people agree with that? So negative 3x times a negative 1 is going to give you positive 3x. And then negative 3x times what gives me a negative 6x to the 4th?
Plus 2.
Plus 2 cubed. Is everybody okay with this? All right. I don't think we can factor this guy any further, so I would just leave it like that. Now, let's try this one. I'm going to give you some time to copy that down, because that looks like a good thing for us to practice. So go ahead and write that one down, please.
For the before question, does it matter if you take out the negative or not?
That's a good question. No, we could have factored out 3x or a negative 3x. Either one is okay. Vince,
I had a question for the first example because
this one,
the one right before it
this one,
wouldn't, because there's a 4 in it,
yes.
and that is not prime. So couldn't you factor it more?
But when we talk about prime, we're talking about the whole factor being prime, not just a number inside of that factor. Does that make sense?
Yeah.
So this factor right here is prime. This whole 4x squared minus 3, this is prime because I can't factor anything out of that whole factor, right?
Okay.
And this, you could say, well, 2x squared is another factor. That's also prime. I can't factor anything out of that. Does that make sense?
Yeah.
All right. There's the question. All right, so everybody's had a chance to copy this down? So with this one, so with this one, I want you to think of this whole thing here as one term, and this whole thing here as another term. I kind of like to put boxes around them because it kind of makes them pop a little bit more. All right, and so in this, do you see anything that we could factor out of both of these terms? What do you think, Shelby?
You can factor in an x.
An x. All right, so I see an x here, and I see an x to the 4th here. So I can factor out an x. What else could I factor out, Noah?
3.
Because you're saying 3 and 3 goes into 12, so we need a 3x. Anything else that's appearing in both of these, Kate? X plus 5 to the what? To the first, to the second, to the third, to the first. Anything else that's appearing in both that we could factor out? Mariana, x minus 7 to what power? To the first. Does everybody agree with that? Because if I've got x minus 7 to the second and x minus 7 to the first, I can only factor out x minus 7 to the first. I got to go with the lower of the two powers, right? Just like we did here. We had x to the fifth and x to the second. I had to factor out the lower of the two powers, correct? All right, so back to business here. So that's all, those are all common factors that I'm going to factor out. I'm going to put like kind of a big bracket here so I can figure out what I need to have, what's remaining. Here's what I want you to picture. I want you to picture this. I want this whole quantity here times what am I going to put here, is going to get me back to this whole first box. So what am I missing? What do I still need to multiply this first thing by to get back to that box? Kate?
X minus 7.
X minus X minus 7 just to the first?
Yes.
Yeah, do people agree? Because x minus 7 times x minus 7 would get me back to x minus 7 to the second. Other than that, we have everything we need, right? And now I'm going to put this plus, right? And then I want you to do the same thing, but it's going to be this whole factor here times what is going to give me this second box. So what am I missing? What do I need? Faith.
4x cubed.
So you're saying you need a 4x cubed. You're saying because 3x times 4x cubed will give us the 12x to the 4? All right, anything else that you need?
X plus 5 in parentheses and then squared.
X plus 5 squared?
Yeah.
Anything else that we need?
No.
Are people okay with this? Does that make sense? And really, we now have it kind of factored because we've got, you think about, I've got 3x times x plus 5 times x minus 7 times this whole thing. I've written our two terms as a product of few factors, right? The only thing is I would like you to clean up this last term. Let's simplify this term as much as possible. So I would probably start by doing x plus 5 quantity squared. Is that x squared plus 25? I hear yes, I hear no. Lucy, what's her? All right, because we need to do x plus 5 times x plus 5, and that's going to be, if I do FOIL, I'm going to get x squared plus 5x plus another 5x is 10x plus 5 times 5 is 25. Everybody agree? So if I just write this, I'm missing the 10x term. Agreed? All right, so let's clean this up a little bit. So I'm getting rid of this. All right, I'm going to tap. Okay, let's see. So I'm getting rid of this. All right, so that's this part right here, but I still need that whole thing multiplied by 4x cubed. Is that right? Yes? And so if I distribute here, I get 4x to the 5th plus 40x to the 4th. Am I doing that right? That look okay? Plus what? 100x to the 3rd. And then don't forget, I still have to add on the x and the negative 7. X minus 7 plus this. So this whole thing, I could put it in standard form, like descending powers of x or something. But I don't think I have any like terms here to combine, right? So I think I would just leave it for right now. And don't forget, I still have to multiply this by this x minus 7, and this x plus 5, and the 3x, parentheses optional for the 3x. Are we okay with this? This.
wouldn't you still have to separate out the x minus 7 with the rest of it? Because the term that's on the outside of the parentheses has to be multiplied by each part separately. But there, it's just adding more terms for it to be multiplied out.
Are you talking about this part here?
Yeah.
All we did was we took what was in this brackets and we just simplified it. We had to multiply this all out, we had to distribute the 4x cubed, and we just combined it with the x and the minus 7. But there were no like terms, so we couldn't combine anything. So we cannot simplify this factor any more than that. And there's nothing we can factor. I don't think this thing's factorable. So I think we have to just leave it. Does that make sense?
Yeah.
So then this whole thing, these, I guess you could say these, 1, 2, 3, 4 factors, if we were to multiply this all together, it would be equivalent to what we started. All right, Lucy.
So you do not, like, foil, yeah.
Oh, here?
Yeah.
Great question. So do we need to multiply these out? If we multiply these out using FOIL, we're going to be kind of undoing the factoring. And our goal is to have it as, get it as all factored as possible. So if we kind of multiply this out, we're kind of going backwards.
That's what I was thinking
Is that what you're asking?
with like the ones in the brackets.
Which one's in the bracket?
The terms in the brackets, because you simplified all that. So I was
Okay.
thinking if you could simplify that, then you can't simplify the ones outside.
Yeah, but this cannot be factored. We can't factor anything out of this, right? I mean, it is what it is, and we can just multiply it out to simplify it, but it can't be factored. And it's certainly not any easier to work with in this state than this state. All right.
Okay.
All right. Okay, so that brings us to special factoring forms. Can you take a look at page A29? On page A29, you are introduced to some special factoring forms. And starting with the difference of two perfect squares, which we've already talked about a couple times today. So there is a formula for, if you have a perfect square minus a perfect square, that can be factored into u plus v times u minus v. Can we factor, and then we did that for x squared minus 9, right? We factored that into x plus 3 times x minus 2. Could we factor something like x squared x squared plus 9? Can that be factored? Stunned silence. Kyle, you're shaking your head.
No. Because we're introducing x squared plus 6x plus 9. If that was factored
you're saying
into x plus 3.
You're saying if you tried to factor it into x plus 3 times x plus 3, we'd end up getting x squared plus 3x plus another 3x. We're doing FOIL, and we get x squared plus 3. So this guy is factorable into this, but this guy is just not factorable. So that's I ran out of room. But that's the key takeaway here, is that we can factor a difference of two perfect squares. We cannot factor a sum of two perfect squares. This guy is not factorable. Everybody with me? We can factor a difference of two perfect squares, but not a sum of two perfect squares. What else do they have on here? They have factoring forms for perfect square trinomials. So for example, if I want to factor u squared plus 2uv plus v squared, if I have something in this form, it will factor into u plus v times u plus v, or I could write it as u plus v quantity squared. All right, let's pause for a moment before we look at any others and factor this first one. Can we do this? Is 25x squared a perfect square? Yes, is 1 a perfect square? Yes, it is. 1 squared is 1. All right, is there subtraction in between? Right, because it won't work with addition, right, but it will work with subtraction. But before we just kind of blindly go ahead and do this, I do want you to tell me, what would I need to square in order to get 25x squared? Caitlin. 5x, do people agree with that? Yes, so 5x times 5x will get me to the 25x squared. Now, what would I need to square in order to get the 1, Francesca? 1, all right? And so here's my point. Slide this down, slide this down. My point is this. We're going to use that formula for factoring a difference of 2 perfect squares. It looks like this. But this right here is going to be our u. You with me? And this 1 is going to be our v. So come on, say, oh, let u equal 5x and let v equal 1. So now I'm asking you to use this formula, and you're going to plug in 5x wherever you see a u and 1 wherever you see a v. Helping me out with that is Billy.
End up being 5x plus 1 times 5x minus 1.
Does that make sense? All right. All right. Let's fast forward down to this problem. And for this one, I see 3 terms. Is this a perfect square here? Yes. Is this a perfect square here? Yeah. So far it's kind of fitting this pattern, right? A u squared and a v squared, right? And then if this middle term happens to be 2 times u times v, then we're golden and we can use the formula that we just talked about. Did I write it? I just read it. I wrote it right there. I can factor it into u plus v quantity squared, right? Okay, so how do we test this? So again, I would say, slow it down and say, what do I need to square in order to get 4x squared? Shelby? What do I need to square in order to get 4x squared? 2x. And Shelby, what do I need to square to get 9? 3. So in this case, I think Shelby's telling us that our u is going to be 2x. Agreed? And our v is going to be 3. So my question is, what is 2 times u times v? Because if it's equal to 12x, then we've got a pattern fit in here. Yes? So what is 2 times 2x times 3? What is that equal to? 12x. So we are in business and we can use this formula, right? And so that means that this whole thing is going to factor into what? We're plugging in 2x wherever we see a u and a 3 wherever we see a v, because it fits that pattern. Kyle?
Parentheses 2x plus 3 squared.
Are we okay with this? All right, that brings us to this guy, 27x cubed plus 64. For that one, I think we're all going to have to look back at page A29. And it says there are 2 formulas there, a sum of 2 cubes formula and a difference of 2 cubes formula, which means that we can factor something of the form u cubed plus v cubed. That's going to factor into u plus v times u squared minus uv plus v squared. See, it's a sum here, right? That's a sum of 2 things. But if I write it like this, it's a product of 2 things, right? It's factored. Much nicer form. All right. So so that's the formula for sum of 2 cubes. Remember, there was no formula for a sum of 2 squares, right? No such thing. But there is a formula for difference of 2 squares, but no sum of 2 squares. But there is a formula for sum of 2 cubes, and there's a formula for the difference of 2 cubes. Looks very similar. A couple sign changes. Right? So for this problem here that we're trying right now, let's go down. So for this problem here, is 27x cubed a perfect cube? You got your list of perfect cubes. We see 27 is there. So what would I need to cube in order to get this first term? What would I need to cube in order to get that second term? A little help, Mariana. What do I need to cube to get 27x? 3. 3 cubed will get me 27, but I want 27x. 3x. Do people agree with that? All right, and what do I need to cube in order to get 64? Count our way down here. 1, 2, 3, 4. Are we okay with this? So that means that we're going to let u equal 3x. I know it's going to be our u, and this is going to be our v. Let v equal 4. So we are using this guy here, right? Because we're doing a u cubed plus v cubed. And I need a little help. And what am I going to be writing and putting in these parentheses? Data.
3x plus 4 in the first parentheses.
So we're using this one, right? And so you're doing 3x plus 4 because that's what we're letting u and v equal to. Okay?
And then 3x squared minus 3x times 4
Times minus 3x times 4
plus 4 squared.
plus 4 squared. Do people agree with this? Cole, you're shaking your head. I'm not Cole. No, why you're shaking your head?
Wouldn't the first parentheses be 3x minus 4? Oh, wait, no. Wait.
There is something not quite right about what I wrote. What's not quite right here, Helen?
Don't you have to put the 3x in parentheses because of
Yeah, because the u, the whole u has to be squared. So I do need to write it like this with the 3x in parentheses because that's going to make a difference. And our final answer is going to be 3x plus 4 times, is it going to be 9x squared minus 12x plus 16? Does that look okay? All right, I don't think that this is really ever factorable further, so I wouldn't even bother trying. So I think this is going to be our final answer for factoring the 27x cubed plus 64. All right. By the way, if we were going to try and multiply this binomial times this trinomial, remember last time we talked about using the box method, remember? And I said, oh, if we put like a 9x squared minus 12x, 16 here, 3x here, 4. If we multiply, fill in all these boxes and combine all like terms, what are we going to end up with? What do you mean same thing? What do you mean? Yeah, what we start, we're going to end up getting this. All the terms are going to subtract off and things like that. And we're just going to be left with 27x cubed plus 4. Does that make sense? You can certainly try that for fun if you like. Okay, so this right here is just another example of factoring by grouping. Okay, so I don't want to do another practice of factors. We did a couple of those, but that brings up, that's another factoring. That looks like a difference of 2 cubes, doesn't it?
Yeah.
But what I want to skip to, I want to skip to this very quickly and remind you of how to do the product sum factoring. Does that sound, those words make sense to you if I say factoring using the product sum technique? No, you didn't learn this in, pardon me? AC factor, so that you multiply the A times the C? Yes. So if I want to factor something of the form AX squared plus BX plus a quadratic trinomial, then the product is going to be the A times the C. And the sum is going to just be the B. All right, this is called product sum technique for factoring the quadratic trinomial. So, let's try it out really quickly with this one, and then we're going to take our quiz. First of all, I'm just going to look for common factors. Any common factors here? Anything we can factor out of all three of these? 2. So I'm going to factor out a 2, and I'm going to have, is it 10x squared plus x minus 3? Does that look okay? All right, and then if we want the product and the sum, the product is going to be what? I need my A times my C. Negative 30 is all I want to write down. All right, I'm just multiplying the coefficients, including the signs. And then my sum is going to be what? 1, because that's my coefficient on the x. So I'm looking for 2 numbers that multiply together to give me negative 30 and add up to 1. What 2 integers multiply together to give me negative 30 and add up to 1, Lucy?
6
A positive 6 and a negative 5. Do people agree? 6 times negative 5 is negative 30. 6 plus negative 5 is 1. True? So here's how the product sum technique works. We've already done all the hard part. And now we're going to take out this 1x. We're taking out that middle term, and we're going to replace it with 2 terms that add up to that term. Negative 6x and a negative 5x. So I'm going to write down 10x squared plus 6x minus 5x minus 3. Everybody with me? And now we're going to do the factoring by grouping. So I factor out something from 10x squared plus 6x. What can I factor out? The 2x. So I get 2x times, is that going to be 5x plus 3? Does that look right? And then what can I factor out of a minus 5x minus 3? A negative 1. So I can either factor out a 1 or a negative 1. I think I would choose to factor out a negative 1 so that my 2 parentheses will match. Agreed? And so then I'm going to have 5x plus 3 times 2x minus 1 as my answer, but don't forget I had this guy that I factored out originally, so he's got to be along the line. So this is going to be my final answer for this. Questions on this? Okay, so that's factoring using a product sum technique. Your book calls it factoring trinomial by grouping. We wrote it and then we factored by grouping. Okay, so that's it for this video. Thanks for watching.